Okay, we are going to start with exponent rules. What I'm going to do is I'm going to do an explanation in here, and I'm going to leave these examples blank so that you can try these on your own. For the product rule, if they have the same base, so if terms have the same base, so x to the fourth times, and we're multiplying, x squared. Think about what this means. It means we have 4 x's times 2 more x's. So we have 1, 2, 3, 4, 5, 6. So I have x to the 6th. So a shortcut of that is just to remember that when you're multiplying numbers with the same base, add the exponents. Okay, so if we had negative 3 to the 5th times negative 3 to the 11th, it would be negative 3 to the 16th power, because we're multiplying, therefore we add the exponents. Power rule means that we have excuse me, a quantity raised to a power. I'm out of focus, just a minute. There we go. Okay, so if I have 5 cubed to the 2nd power, that means I have 2 of these. So if I expand it, that means I have 5 cubed times 5 cubed. We're right back to the other rule of the product rule, so we would add the exponents. So 5 to the 6th power. So if we look back, what we are doing here is we are multiplying. So if there is an exponent immediately outside to the right of parentheses, you need to multiply. If I have 2x to the 4th power, this might even be a little bit more with the power of a product rule, but this exponent has to go to all of the exponents in the parentheses. Again, it means we have 2x times 2x times 2x times 2x. So just like up here, I multiply the exponents. So I multiply the exponent of 1, which is understood, times the 4, which gives me 2 to the 4th, x to the 4th. 2 to the 4th ends up being 2 times 2 times 2 times 2. 4 gives me 16 x to the 4th. Quotient rule. Quotient means division. So we are going to be dividing. So if we have 16 x to the 5th over 24 x to the, we'll make it a 7 for right now. The most common error is to be looking at the 16 and the 24 incorrectly. What we are doing here is, if you think about it, we have x times x times x times x times x over 7 more x's. And when we cancel them out, they divide by each other and give me a 1. That leaves me 2 x's in the denominator. So if I simplify the 16 and the 24, 8 goes into both of these numbers. So I end up with a 2 in the numerator, a 3 in the denominator, and I have x's in the denominator. So when you are dividing, you are subtracting. I'm going to do another one of those just because it is one of the harder ones. I'm going to kind of squeeze it over here. If you have m to the 8th over m to the 5th. So if you visualize, I have 8 m's over 5 m's. So if I start canceling them out, I end up with m to the 8 minus 5, which gives you m to the third. Typically, I don't think of it this way. I look at it as if you have a higher number on the top, this is where your leftovers are going to be. If we look over here, we had the higher exponent on the bottom, so that's where our leftovers were. So I still subtract them, but I put the leftovers wherever the highest exponent was. Power of a product. This is what I pretty much did up above. So if you have 3 squared x to the 4th to the 3rd power, this exponent has to go to every term. Now it is not 2 to the 3rd, just like up here we multiply. So we have 3 to the 6th, x to the 12th, and then 3 to the 6th. I'm going to cheat with my calculator. Gives me 729. X to the 12th. So you just have to make sure it goes to every term inside. If there's a negative number, depending on what this exponent is, if it's a 2 or a 4 or a 6, if it's an even number, again, if you think about this being a 2, that means I have negative 4m to the 3rd twice. And a negative times a negative would give you a positive. But if I make this an odd number like a 3, I'm going to have 3 of these quantities. So negative 4m to the 3rd times negative 4m to the 3rd times negative 4m to the 3rd, and that would give me a negative number at the end. So it's going to depend on whatever I put here. So I'm going to put a 3 here. So that means that this goes to the 1. So negative 4 to the 3rd, m to the 9th. I know this is going to end up being a negative. Again, I'm going to kind of cheat. 16 times 3, and I get negative 48 m to the 9th. Power of a quotient. Quotient again means division. So if you have 3m over n to the 4th, and that whole thing is squared, this goes to every single factor inside. So that would give me 3 squared, m squared. The exponents outside the parentheses, so I multiply these exponents. N to the 8th gives me 9m squared over n to the 8th. On the back side, these are ones that we've already done. I'm going to go ahead and just do these examples since they're already here. This x is the only one with a negative number. So the negative 5 actually has an exponent of 1, so it does not move. But then the x goes to the other side of the fraction and becomes a positive exponent. On this one, we have a 1 and a 2. When we simplify 4/8, we have 3 k's on top and 5 k's on the bottom. The reason why this is in the negative exponent category is because the book would have you doing k squared minus 5, giving you a negative number, which then you're going to have to move that number back down to the denominator. I use the common sense of there's 2 here, there's 5 here, so if I subtract them or divide them out, I'm going to have 3 k's left in the bottom. Zero exponent we've already talked about. One thing we need to address is that if you have something like that, 4ab to the 0 power, it is only the b that is raised to the 0 power. So you'd have 4a times 1, which would give you 4a. So pay attention to that. And fractional exponents you will be covering in Algebra 3-4. That's it.